Hi, welcome to Mathematics Applied. My name is Parthiban, and here I am with the story of physics for Standard 12. The chapter going on is electric charges and fields. The episode is basic properties of electric charge. We know what electric charge, how it is created, all that. Now, having known that, we should know what are the basic properties of electric charges are. What do we do with that? No, what are the properties? What is its property? What is its property? You have n number of charges. Okay, that charge. An object has n number of charges, or you have n particles with different charges. First particle having n1 charge, second particle n2 charge, then the third particle n3 charge, like that. You have n number of particles. Then what is the situation? What is the property of charges? This is what we are going to talk in this episode. If you have n particles with different charges and you bring all those particles, put them together, what is the total charge going to be? Some particle might be having negative charge, some particle might be having a positive charge, isn't it? So if you put all those particles together, what would happen to the charge? How much will be the charge? What will be the value of the charge for the combined particle? N particles, you have combined them. Now what is the charge on the combined particle? That is one particle, right? How much is going to be the charge? What are you going to do for that? You just add those charges. The total charge is going to be Q1 plus Q2 plus Q3 plus Q4, just like that. You just add all the charges. There might be negative charges, there might be positive charges. You just add all of them. So charges can be only added. You are not going to subtract charges. You're not going to subtract them. Okay, it's addition of charges. There is no subtraction of charges. There is no multiplication of charges. Of course, in formulae it's going to come. You have to have q1 q2. If that is the situation, then you multiply. But properties, we are talking about properties. If these charges are going to be on different particles and you combine these particles, then what is going to be the total charge? Then those charges have to be added, right? Whether it is negative or positive, you just add all these charges. What I mean is that if some particle is having plus 2 coulomb charge and the other particle is having minus 2 coulomb charge, you have to just add. Means it doesn't mean that you add that 2 and 2 and get the result as 4. It's not that. It is algebraic addition. That is plus 2 plus minus 2. Minus 2 is the charge on the second particle, plus 2 is the charge on the first particle. Now when you add these, put these particles together, then the total charge is going to be plus 2 plus minus 2, and that gives us plus 2 minus 2, which is 0. So the total charge is 0 there. You're simply adding all the charges. This is what I mean when I say you have to add the charges. You add these charges. By adding, the positive is positive and the negative is negative. If there are negative values, then you have to actually subtract from the positive values. These negative values you have to subtract, because addition means that, isn't it? By simple mathematics, we know this, the integer addition and all, even real numbers addition. But we will not have charges like that, isn't it? Charges in coulombs might be in decimals, but in units of 1.6 into 10 power minus 19 is going to be always either positive or going to be negative whole numbers, isn't it? It's going to be positive or negative integers if it is going to be of units of 1.6 into 10 power minus 19. So in that case, you can simply add all of them. Plus 2, minus 3, plus 6, minus 4, like that. Units. These are units. So that way you can keep adding. In coulombs, they may be in coulombs also, minus 2 coulomb, plus 4 coulomb, minus 6 coulomb, like that. So you just add these charges. That is one property. The second property is, the first property I will read from the book. If a system contains n discrete charges q1, q2, q3, q4, qn, then the total charge of the system is going to be q equals q1 plus q2 plus q3 plus q4, so on and so forth, plus qn. This is the addition of charges. Conservation of charge, that is the second property. Conservation of charge. Total charge of an isolated system always remains constant and conserved. That is, charge can neither be created nor destroyed. So a body will, whatever total charge is there, if it is charged, it is going to be charged forever. Okay? If you bring another object and connect it with that body, only then charges distribute, and then there is going to be difference in the charge of the first body. Okay? If that is not done, if it is kept isolated, then the total charge of the system remains as it is. Okay? The next one, that is conservation of charge. Okay? The third property is quantization of charge. Charge is quantized. Okay? I have been using this unit. 1.6 into 10 power minus 19 coulomb is taken as unit. That's what I have been talking. So in that way, why am I talking like that? Because that is quantization. Charge is quantized. You cannot have 2.5 electrons. Can we have 2.5 electrons, 2.9 electrons? Can we have like that? If we can't have that way, it's always going to be a whole number electrons, right? The electrons are responsible for the charge on the body, right? It's going to lose electrons, it's going to gain electrons. So if it's going to gain electrons or lose electrons, electrons are going out, electrons are coming in. Number of electrons are going to be natural numbers. Or it can be, sometimes electrons has not gone. So 0 electrons. Either it is 0 electron, it is 1 electron, or it's going to be 2 electrons, 10 electrons, 1000 electrons, 1 lakh electrons. It's going to be like that, right? A whole number it's going to be. For each electron, the charge is going to be 1.6 into 10 power minus 19. So therefore, when you take multiple number of electrons, that amounts to n into e. So the charge is going to be 1.6 into 10 power minus 19, or it is going to be 3.2 into 10 power minus 19. What did I do here? I multiplied 2 with the previous one. So 3.2 into 10 power minus 19 coulombs, right? That is the second possibility. The first possibility is 1.6 into 10 power minus 19. In between, 2 into 10 power minus 19 is not at all possible. Okay, that is what is quantization. You understand? Quantized. Charge is quantized. If you start, with 1.6, 1 electron, there is going to be 2 electrons next. There's going to be 3 electrons in the third one. So like that, it moves on. So therefore, a mathematical structure for, this situation, quantization of charge, is going to be the total charge on the system is going to be Q equals plus or minus n times E. Okay, it's always going to be a multiple of E, right? If there are dearth of electrons, that is the system has lost electrons, then it is going to have positive charge, and that positive charge Q amounts to plus n into E, right? The E means that the 1.6, that is the charge on the electron. 1.6 into the magnitude, right? N times E. If it has gained electrons, n electrons it has gained, then its charge, the charge over the body is going to be Q equals minus NE, right? That N is 1, 2, 3, 4, 5, 6. That is what is. A charge of magnitude 1 coulomb contains about 6 into 10 power 18 electrons. That is the charge of magnitude 1 coulomb. 1 coulomb amounts to 6 into 10 power 18 electrons. See, n number of electrons, that amounts to 1 coulomb. 1 coulomb is a very big amount of charge, huge amount of charge. There are so many electrons. 6 into 10 power 18 electrons amount to 1 coulomb. Well, that's what are the basic properties of electric charge. We meet in the next episode. Until then, bye-bye. Have a nice day.